Chapter 14, Developing Fraction Concepts. Fraction experiences should begin as early as first grade. Students partition shapes and refer to fractions almost in grade 1 and 2 as equal shares. Grade 3, fractions are major emphasis with attention to using fraction symbols, exploring fraction units, and comparing fraction. Grade 4 focuses on fraction equivalency and begins working on fraction operations. Part whole. Use the part whole construction in an effective starting point for building meaningful fractions. Part whole can be shading a region, part of a group of people, or part of a length. Division means sharing into equal groups. Fraction instruction should build from experiences of sharing and partitioning. Division is often not connected to fraction, which is what we need to start doing because every fraction is a division problem. Students can determine how many cheese sticks each friend will get and must feel comfortable being able to repeat this quantity as a division and as a fraction. 10 fraction bar 4, 10 inside fraction 10 divided by 4, also written as 10 division symbol 4, 2 and 2/4 and 2 1/2. Measurements involve identifying a length and then using the length as a measurement unit to determine the length of an object. For example, in the fraction 5/8, use the unit fraction 1/8 as a unit and then count and measure to show that it takes 5 of those units to reach 5/8. In other words, 5/8 is thought as 5 times 1/8. Fractions as operators builds on the concept of seeing a fraction as a multiple of the unit fraction. Fractions can be used to indicate an operation, as in 4/5 of 20 square feet or 2/3 of an audience. The fraction 1/4 can mean that the probability of an event is in 1 in 4. The ratio 3/4 could be the ratio of those wearing jackets, the part, to not wearing the jackets, another part. Or it could be part whole, meaning those wearing jackets part and those in the whole class. Area, you can use fractions, fraction circles, rectangles, pattern blocks, geoboards. Example of context in the real world: a clock, pan of brownies, a quesadilla. Length, paper strips, number lines, fraction towers. In the real world: walking distance, travel, string length, music measures. And sets, you can use counters, and students in the class could count the school, the stadium, people that are in there. Area is a good place to begin fraction exploration because it lends itself to equal shares and partitioning. Circle fraction pieces are the most commonly used in area model. The circular model reflects the part whole concept of a fraction and helps students see the relative size of the part to the whole. Grid paper or dot paper provides flexibility in selecting the size of the whole and the size of the part. With link models, lengths and measurements are compared instead of area. Link models are very important in developing students' understanding of fractions. Number lines help students understand a fraction as a number, such as rulers or number blocks or folds of paper. Help students recognize that fractions are numbers and that they expand the number system beyond the whole number. The use of number lines as a central representation tool in teaching this and other fraction concepts from the early grades on. Linear representations may help students understand fraction size because lines are one-dimensional. For example, students can see that a unit that fits into a paper strip 2 times is longer than a unit that fits into a paper strip 4 times. As an example, 3 objects are 1/4 of a set of 12 objects. That the set of 12 in this example represents the unit and the whole, or 1. Another example, putting a piece of yarn in a loop around the object in a set helps students see the whole, as in the figure on the right. can see that they put the hole, and then they put the yarn around the hole, then they put yarn around the area that they are saying is 12, and then you can also break those 12s into subsections. A common misconception with set models is to focus on the size of the subset rather than the number of equal sets in the whole. In an example, if the 12 counters make the whole, then a subset of 4 is 1/3, not 1/4, because 3 equal sets make up the whole. Here's a good example with fractions. Use a group of students as the whole, say 6 students. If you want to use halves, thirds, or sixths, invite them to come to the front of the room. Say to the group, if you are wearing tennis shoes or brown hair, move to the right. If not, move to the left. Ask questions such as, what fraction of your friends are wearing tennis shoes? How many students are in 1/2 of this group? Have students record the fraction symbols and share their answers. If students offer equivalency, one says 3/6, 6, and another says 1/2, show how 6 refers to people and half refers to the group of 2 groups of equal size. Change the number of selection students in the whole. You could have 8 students, 12 students. Sharing tests are generally posed in the form of simple story problem. 4 friends are sharing 2 cookies. How many cookies will each get? Suppose there are 4 cookies to be shared fairly among 3 children. How much will each child get? Notice if you see the examples over here, you have lines being drawn to each student. Then we have the next set that goes to each person. And then we have 2 left, and notice that they broke each in half to make 4, so each person gets an equal share. Students initially perform sharing tasks by distributing items one at a time. When this process leaves leftover pieces, they must figure out how to subdivide so everybody in every person or every group gets a fair share. So if there's 14, they'd have to break those 2 squares up here into 14 equal pieces, or if there was 5 equal pieces. Other example problems. 3 children want to fairly share 15 grapes. How many grapes will each child get? 2 children want to share 5 quesadillas so that everyone gets the same amount. How much will each child get? 4 children want to share 3 cookies so that everyone gets the same amount. How many will each child get? 3 children want to share 10 sticks of clay to make clay animals. If everyone gets the same amount, how much does each child get? Using different models builds a stronger understanding for fractions. The example below shows a whole of 1 breaking down into 6. So you have this whole piece, geometric piece, broken into 6 equal pieces. In the figure, green squares and a red rectangle. A student might think, if I partition this so that all pieces were the same size, there will be 4 parts. Therefore, the smaller portion region represents 1/4, not 1/3. However, the student will be wrong. Each portion is 1/3, even though they're not the same equal size. Some manipulatives like fraction bars or fraction circles can mislead students to believe that fractional parts must be the same shape as well as the same size. Color tiles can be used to create rectangles that address this misconception. Students who recognize that each color represents a third understands the fraction parts must be the same size and not the same shape, may be different. Which of these shows fourth? If you notice that they're all broken into fourths, but each one's broken up in different ways. But if you're saying the same shapes and size, A and F would be the same shape and size. Different shapes, same size, E and G. Different shape, different size, B and C. Same shape, different size, not equivalent, would be D. Students need to be able to partition a number line into fourths and realize that each section is 1/4. So if you have a number line from 0 to 1, 1 to 2, and so on, you break it into 4 equal spaces if it's fourths. So you have 4 spaces, not 4 lines. A good way to help students understand the number line is to create and use paper strips. Provide examples where the shaded sections are in different portions and where partitioning isn't already shown to strengthen students' understanding of equal parts. In Activity 14.7, students are shown different number lines, with Nicole's distance being a different length. Students didn't have to show the length from that point on to the end of 1. Some people, if students show just one tick line, that would be wrong, because the distance from Nicole was not measured accurately. 4 common errors students make in working with number lines. 1. They use incorrect notations. 2. They change the unit whole. 3. They count tick marks rather than spaces between marks. And 4. They count the tick marks that appear without noticing missing ones. Partitioning using a length diagram is strongly recommended and commonly used in other countries such as Singapore as a way to help solve story problems. Consider the following. A nurse has 54 bandages. Of those, 2/9 are white and the rest are brown. How many are brown? Well, you notice that 2/9, these 2 dark shaded green here, are 2/9 of the total, and you have 7 others that are brown. Students can partition with set models such as coins, counters, baseball cards. In the figure below, 12 counters are partitioned into 6. Each share a part of has 2 counters, but it is the number of shares that make the partition show 6th. So you start with 12 and you break them down to 6, so each group has 2 counters. Counting fractional parts or iterating helps students understand the relationship between the part, the numerator, and the whole, the denominator, and to understand a fraction as a number. Students should be able to answer questions such as, how many fifths are in a whole, just as they need to know how many ones are in 10. The numerator is the count or the top number of the fraction. The denominator tells what is being counted, the bottom of the fraction. So in 3/4 we have 3 is the count and 4 is what is being counted. So Emily has 2.5 yards of ribbon. Each ribbon needs a fourth. So we have 2.5 yards, and she's going to break each yard up into fourths and the half into 2/4. So she has 10 fourths in all. So she can make 10 bows. In the figure below, students first partition the piece into 3 sections to find 1/4 and then iterate that 1/4 to find other lengths. Iterating can also be done with area models. In the figure, again, using the context of a quesadilla, or engage students in creating their own fractional pieces using paper plates of various colors, and use these plates to build various fractional amounts. The use of context models and mental imagery can help students build a strong understanding of the relative size of a fraction. You can ask questions like about what fraction of the class are wearing sweaters. After telling answers of data about a topic like favorite dinner, ask about what fraction of the class picked spaghetti. To extend the activity, have students approximate fractions for shading regions in points on number lines or in figures. They can do this on a number line or in shapes. Make sure you ask about how much is it and have them name the fraction. The number line is a good model for helping students develop a better understanding for the relative size of a fraction. Make sure students are focused between 0 and 1 and where fractions are located. If students think about 3/20 might be partitioned on a number line between 0 and 1, they will see that 3/20 is closer to 0, whereas 9/10 is quite close to 1.